Hi guys, in this specific discussion we're going to look at the identities of hyperbolic functions, and this of course are going to assist us in trying to conveniently evaluate some of the problem sets that we may come across which are dealing with the hyperbolic functions. Now hyperbolic functions are going to have identities that are going to be analogous to their trigonometric counterparts, but of course as we're going to mention one from the other, we're going to see that there's going to be some slight variations which we are going to take note of. So for instance, I'm going to give the first example, whereby we're going to have the square of the quotient of x minus, this one is the square of the sinh of x. It's going to be giving us unity. And of course, remember from the trigonometric functions, we're going to have the square of the sine and the square of the cosine of a function is going to give us identity. So there's a difference between that one insofar as this specific sign is concerned. And of course, for the second one, we're going to see that we can be able to represent another identity whereby the square of the sec of x, and then is going to be equivalent to 1 minus the square of the tangent of x, given as such. So that's a second identity from the hyperbolic functions that we're going to encounter. And then we're going to also encounter another set of what we refer to as identity, which is going to be the quotient squared over x is equivalent to the cot square of x minus 1, and that is another identity that we're going to come across. Now of these identities, you can see that the majority of them are going to involve the concept of unity, and of course we're going to take a note of that. So this one, number 4, is going to be somehow different, whereby we're going to see that the sinh square of x, of course, this is going to be the sinh 2x, and this is going to, of course, have a coefficient of 2x, is equivalent to 2 the sinh x, and then this is going to be multiplied by the cosh x given as such. So this is going to be a product, this is a coefficient of 2 and the product of this sinh of x and the cosh of x given as such. And then we're going to have perhaps last but not least, the cosh square of x, or the cosh of 2x. This is going to be an analogy of the first one. It's going to be equivalent to cosh square of x, and then plus sinh square of x. So this is roughly the same as the trigonometric function, which is the identity of a cosine squared x plus sine squared x, only that its specific, of course, product is going to be, or the sum of the two is going to be contrary to the unity in trigonometric functions. This is going to be the cosh 2x given as such. So therefore, as we come across various applications of this specific identity, I presume that we are going to perhaps try to figure how we can be able to represent them in trying to, of course, I cannot encourage us to memorize them, but as we continue applying them in various areas, I presume that we are going to understand and comprehend how we can be able to represent them just as they are going to appear in this specific case. So catch us in our next video as we're going to look at perhaps a problem set which is going to assist us try to represent various hyperbolic functions that we have already discussed, and this is going to form a basis for us in trying to of course tackle other areas of application that we're going to come across insofar as hyperbolic functions are concerned. So that is it for now guys. Catch us in our next video.